Hello, everybody, and thank you for joining us for Operationalizing Iceberg metrics with OpenLineage. My name is Gemma, and I'll be your moderator for the session. Just a heads up that we will have time for a brief live Q&A after the presentation. So please be sure to use the Ask the Speaker tab to ask questions and engage with your fellow attendees. So with that, I'd like to welcome our speaker, Pawel, with Astronomer and Getting Data to the stage. Take it away.
Hello, everyone, and thank you all for coming to our today's talk. And thank you, Iceberg community, for having me here. I'm going to drive you through the next 45 minutes on operationalizing Iceberg metrics with OpenLineage. So I bet you're familiar with Iceberg community. I don't know if you're familiar with OpenLineage community, but I hope I can argue and convince you that there's a great synergy that can be a result of those two communities having a common solution and working together. So my name is Pawel Leszczynski, and you can find me on GitHub as Paweł Wiklabowski. So don't ask me what's my favorite movie. And for the last 3 years, I was a full-time committer of the OpenLineage project, and I was working mostly with the Apache Spark connector for OpenLineage, Apache Flink connector, and also for Marquez, which is kind of a reference backend architecture for OpenLineage. So this was possible because of Getting Data, part of XIDA company, which is a Poland-based consulting company, which allowed me to be hired by big tech giants to spend my time working on the open source and either extending the features of OpenLineage or fixing the gaps and making the project work even better. What is planned for today? So actually the agenda is pretty stacked. So we'll start with a motivating example because I believe that example-based stories are best to understand. Actually, we will skip the second bullet, what is Iceberg. So I put it here just to check if the slides are censored, but they are not. A silly joke. Third bullet is Iceberg metrics, and perhaps you may be familiar with this, but I think it's valuable to revisit those and see what you can find out of metrics available within Iceberg. And this will lead us exactly to OpenLineage. And if you have no idea of what OpenLineage is, it doesn't matter. We'll have the introduction to this, and we'll guide you through what problem does it solve, what does it contain, and what it's all about. And we're going to have a demo, or at least show a demo with a real life problem that can be solved with Iceberg and then OpenLineage together. And this will lead us to Iceberg metrics used together with OpenLineage, and at the end, some final thoughts and recap. I think we're going to have some time for Q&A. So you can ask the speaker and use it right away. So we can start with the ancient Hadoop cluster. So it was back in 2010. So I was taking care of one of the biggest Hadoop clusters in Central Eastern Europe. And we're doing our best in planning the resources and buying new hardware. And from time to time, we failed. So there are many reasons behind this. So there was like a flood in Taiwan, which flooded the disk manufacturer. Or it turned out that we're running out of space in the rack of Hadoop servers, so we can put them physically. And actually, from time to time, we're put in the situation where, hey, we're going to run out of resources, so we are growing too fast and we're not able to buy enough hardware. And these were like sleepless nights and a lot of stress, but actually there was one really cool thing about it. And when I think about it right now, it's kind of a blessing. So from time to time, we're put in a situation, hey, we have a few weeks, we need to revisit our jobs and see if we can do things better. Because for most users, if they have some performance issue and if they can solve it by throwing more resources, throwing more money, more electricity onto it, they're happy to solve it this way. But from time to time, we are put in a situation, hey, we need to try to make things more efficient. Because there is no other way to do it. And and when looking at the jobs, we found out that actually there are like common pitfalls that users do. And those were mostly related to the SQL users, because for a SQL user, if your query returns a proper result, then you're all correct with this. So those users sometimes don't care that much about the performance. And yeah, it's common that tables have multiple datetime fields, and the tables are partitioned, and actually they are partitioned only on a single datetime field. And the users may be not aware which one of the field it is, and they do filtering on the other fields. And actually, if the table is really big, then, you know, from the few seconds, the query gets to a couple of minutes or even longer, which is kind of a problem. But yeah, if they trigger it every day and introduce the problem at some point, yeah, then perhaps they will not even notice this. But the problem gets even bigger if there are two tables and the filtering is done wrong on each of them, and then someone tries to join them, because this can make the thing explode. Yeah, so we're going to read so much data and try to copy them through the nodes so many times that this can really harm your cluster. And yeah, so actually, yeah, this is the experience from like 10 years back. And so the lessons learned from this were that users prefer scaling resources than looking at their code. And if you want to make them write a better code, you need to have a great automatic tool that tells them exactly this is the place you need to fix. Yeah, otherwise this will not work. The other lesson learned was that SQL job is done well if it returns desired results. It doesn't matter if it can be written in a more performant way. That should the data ecosystem do. And for me, the hardest lesson learned was that I wasn't able to build a tool that automates manual interventions. So I was able to find out what are the common pitfalls, what goes wrong, but only by looking at the job. I couldn't do it automatically on the old jobs that were running. And yeah, having this said, we can move next to I think Iceberg metrics, because the slides are not being loaded. Oh, so yeah, the picture on the right is as if was dropping a stone on his toe. Oh, Gemma, I think I need your help, because there's something wrong with the next slide button. It's like, oh, I can't even hear you. What do I see?
Hello, can you hear me now? Is that the right slide?
Yeah, it's the right slide, and it's working back again. So sorry all for interrupting.
No worries.
Yeah, we're fine. Great. So this brings us back to Iceberg metrics, and yeah, actually, you know, as of Iceberg version 1.1.0, Iceberg supports the metrics reporter and adds the metrics report APIs. And there are two most common and two only available metric reports, and this is the scan report, which carries metrics being collected during scan planning against a given table. But also there is a commit report, which carries metrics being collected after a table is written to. And yeah, within the Spark Iceberg connector, there is a REST metrics reporter, which allows you to emit the metrics to an endpoint wherever you like. But there is also an ability to implement a custom reporter. And actually, this is one that we have used within OpenLineage integration. So if you look at the example commit report, that's the commit report from Iceberg documentation. It contains some commit metrics, which can be really interesting. And actually, you know, the most interesting can be like the total amount of records written or the file size in bytes added. And yeah, if we look at the scan report, we can see what kind of filtering was applied on the table. We can also see other metrics like the skip data files. And yeah, so So there's a demo attached to this talk, and you can visit it under this QR code. It's available in GitHub under the OpenLineage workshops, and it's based on the New York City taxi data. And to run the demo, you just need to run Docker Compose app, and you will have two containers started. One is a Jupyter notebook, which will run the Spark session and where you can run the Spark code. And another one is the Marquette, which is OpenLineage backend application that collects the Lineage events and has the web UI to see the graph, and API to answer Lineage queries and API calls. So actually there are three tables within this demo. So one is the yellow trip data from the publicly available open New York City taxi data, which I enriched with the ride ID table. Then we have added users ride reviews table, which for a fraction of trip data adds some users a free text comment about the ride and reference to a ride ID. And based on this, there are monthly aggregates evaluated. So yeah, the demo is based on those three tables. And so the job is simply reading the table, joining with another table, and writing to an aggregate table. So within Iceberg metrics, we are generating, scan reports for each table being read, and so for the trip data table, also for the user's comment, and when writing to an aggregate table, we are creating a commit report, and this seems okay, except for the one thing that I would say that is missing here, or could have been done way better with the OpenLineage project. You don't have a correlation between the scan reports and the commit reports. And this is something that you can solve with OpenLineage. So not only you will have the metrics report, but you will be able to link them and somehow to find out that, hey, those commit and scan reports belong to the same job. And how to solve this? Actually, this can be solved with OpenLineage, and this brings us to another section on what is OpenLineage. So let's start with the problem definition that OpenLineage tries to solve. So the purpose of the project is to help people build a healthy data ecosystem. And actually, modern data ecosystems are pretty complex and involve several data sets, teams, and relationships between them. So, one team is writing to a dataset, another one is from this, and actually, frequently, dataset is the only API that connects them. So, in such ecosystems, there are several interesting questions like what is the data source, what is the schema of the data, who's the owner, how often is it updated, where does it come from, and some of these questions can be answered with a data catalog like Iceberg. But some can't, and some require something else, like who is using it, what has changed, how often is a job, is dataset updated, or a query is run. And you need Lineage to understand those relationships between the data sets. And how to collect Lineage? Actually, there are two ways you can do it. So the traditional approach would be to look at the logs of the jobs and try to find out the Lineage out of it. And it used to work, but it has some limitations. So imagine that your log file contains select star from table query. And, if you're just scrapping the logs, the star means nothing to you. However, if you were able to, inject your Lineage extraction metadata code directly into the processing engine, you'd be able to resolve the star and find out what fields or columns are hidden behind it. And this is like the analogy similar to finding out when and where was the photo taken. So you come back from your holidays and you can look at the photo and try to figure out when did you take it, what was the time. But actually you can get the same data even more accurate if the camera does it for you, because you can have the GPS location and the exact time. And so you can get more accurate data. The only thing is that all the cameras worldwide need to implement it, and there has to be a standard so that this information, this metadata, is embedded within the image file. And this is the approach OpenLineage has taken. So we believe that whenever data is processed, the lineage metadata has to be extracted directly at this particular moment. And we believe there has to be connectors to like Apache Spark or Airflow that collect lineage directly when data is processed. Okay, so what is OpenLineage? One answer would be that it's an open platform for collection and analysis of data lineage. It contains libraries for common languages, integrations, and data pipeline tools. There's also a metadata repository, reference implementation that we call Marquez. Actually, it's a separate project. It's a web app that consumes Lineage events and is able to present them in a UI and has really rich and extensive REST API to ask me anything about the Lineage. So another and perhaps the more precise answer to what is OpenLineage would be it's an open standard for Lineage data collection, which defines a generic model of a dataset, job, and run entities within consistent naming. And yeah, to stress the thing, consistent naming is crucial because if we have one job writing to a dataset and another one reading from it, if we name the dataset in the same way, we are able to build graph on the top of it and to connect it via edge. And if the naming is not consistent, then the edges will not match, no edges will be added. So those three concepts can be extended with facets, and the facet is a user-defined metadata and enables entity enrichment. So this all makes the core model highly extensible via facets, and OpenLineage as a standard comes with plenty of useful facets. And if you think they are not enough, you can extend it with custom facets added of your choice to contain some information that you find valuable within your organization. So how does OpenLineage events work? So Lineage is reported as a series of asynchronous events, and it is the consumer and the backend who need to aggregate and merge those events. So each event passes a unique client-generated run ID, and it is the backend who needs to pick up the events with the same run ID and merge them into the meaningful overview of what happened within the job. So the typical series of events contains a start event of a run, which can have some input datasets, some run parameters, perhaps the source code version information, and then complete event with output datasets and dataset version. So for the dataset version of the output dataset, it makes sense only to send it for a complete event, because at the start you don't know what the dataset version will be. And actually, OpenLineage, the standard, does not define when facets should be sent. So you can send input dataset on start and on complete, but actually it's the consumer and the backend work to merge it into the whole view of what happened within the job. So the life cycle of a job run is that, we have a start event, and then there are three possible complete terminal events like the abort, complete, and fail. And actually, it's really important for the consumer to know that these three are terminal, because it tells the consumer, hey, I don't need to wait anymore for other events related to this particular run ID. So the event model is that OpenLineage emits the events and the integration tries to be as stateless as possible. So each event, or most of the events, correspond to run state updates. And actually, each event is built on the three main building blocks. It's the run, which contains client-generated run ID and perhaps some run facets. It contains also a job section with name-based job ID and job facets. So it's clear that if we run the job every day, then we'll have the same job name, but we'll have different run IDs. And this correlation will allow us to find out later that there were some parameters of the job that changed over time, and we can expect something is happening here. And also each event contains inputs and outputs, which are crucial to build the lineage graph. And these are datasets, and each dataset is name-based and can be enriched with facets. What facets can we use? So for a data set, it makes sense to have a schema as a facet. It makes sense to have some ownership information, some version information, and the column level lineage. And this can have many different levels of support. For example, the initial level of support is just to find out the dependencies between the input fields and the output fields to know what field has been used to create certain output field. But actually for Spark integrations, we extended it to contain even the information about transformation, so that not only you know what fields were involved in processing an output, but you know what function, what operation was used. This is useful to track, of course, sensitive data, and this is useful when you do some hashing, because after hashing, the data may be considered no longer sensitive. So some examples of the facets of the job facets. If it's a SQL query, why not to include SQL? A job type, which can be batch or streaming, link to the source code makes sense as well. So examples of the run facets can be a schedule time, some environment properties, processing engine version, which can change over different runs of the job. And if a job fails, why not to have an error message included? So this all can be contained within the events, and just to show what problem is OpenLineage solving. So the world of a lineage can be split into producers of the lineage metadata and consumers of the lineage metadata. And assuming you have like n producers and n consumers and no standard in between, you're going to have n square integrations, and that's not going to work. And the problem that OpenLineage solves is that if you decide to have a common standard in between, then you limit the complexity, because you just need all the producers to speak OpenLineage and all the consumers to understand OpenLineage format. And whenever you want to add a new tile to this graph, and to the left or right, it's a way easier. So what's the key success factor behind OpenLineage? Because all those tiles are the real technologies that support OpenLineage. And I would say the key factor behind the success of OpenLineage project is the ability to automatically extract lineage metadata. So, we live in 2025, and actually lineage is not that common, and it should be. And I think it's because that traditionally it was not doable to extract it automatically, and our integrations like Apache Airflow and Apache Spark were crucial to the project's success. I was working mostly with Apache Spark, and the beauty of this is that you add the OpenLineage jar, you specify where you want to send the OpenLineage events, and the connector injects to the running logical plan of a query and extracts lineage out of this. You don't have to do anything more. So if you are about to add some, custom code and custom manual specification of inputs and outputs, this wouldn't work. The beauty of OpenLineage is that you can turn it on globally for the whole ecosystem, and it will start collecting the data. And when you collect the data, you do have plenty of possible consumers that can work with this. So, you can start with Marquez or Oleander. Marquez is open source reference implementation. So, if you're in testing phase, you just start a Docker or run the app and see what kind of lineage graph are you getting. Oleander, the dev is a software as a service, but it has some free tiers, so you can start without paying anything and see what benefits you can get from the lineage. And at some point, when you see the benefits and you want to go in production, you can use solutions like the Atlan, which is the enterprise data catalog, what the enterprises need with all the features within it. So when we go back to the demo, actually instantiating Spark session with OpenLineage is as easy as this. So there are like few lines added. So I added the OpenLineage jar. I added the extra listener that points to OpenLineage Spark listener. I provided 2 parameters which tell what to do with the OpenLineage events collected and made them somewhere. And yeah, I was able to configure some ownership information that can be useful within the organization to identify who's the owner of the job. And yeah, once you run the demo with the New York cap, New York City tax data, you'll see the graph in Marquez that is going to look like this. It's nice, it's shiny, but just little value on the graph, I would say. Or I would say you can get even more value out of this Lineage metadata. So suppose we're running a common pitfall and we do have a full scan. So we do have two tables which are partitioned by a month, and for some reason when joining them, we filter only a single of them on a month, and we don't filter the other table. So the results will be the same, just that query takes way longer. And how can this be solved with OpenLineage? So actually, no, you've got a consumer or a backend where you emit all the events, and you can go through those events with a few lines of scripting and accessing the Marquez API. And you can try to find all the jobs that have read more than 1 gigabyte, 10 terabyte, or whatever value you say of bytes. And yeah, and the Iceberg scan report with the skipped files was equal to 0, because this means that someone is reading a lot of data and actually is not skipping any files, so it's not using any partitioning. And because we have tags, ownership tags attached to a job, we can easily identify those teams and contact them and say, hey, is this really what you're going to do? And yeah, and it's just an example. Yeah, it's just an example of how few lines of code can go through all your jobs and try to identify the potential pitfall that people may run into. So you can write more rules, and with such a rule, you can, connect to all the jobs within your organization. So yeah, and actually, what you can say about this demo is actually that, hey, but actually I was able to solve the same with just Iceberg, because there's no OpenLineage needed here to solve this. And there's another type of problem that you can run into, and actually this one is the one that OpenLineage is required. So imagine there's something wrong with the data and your aggregate for a particular month returns 0 rows. So imagine a monthly job that writes no rows because of an empty input dataset. So this can be solved and identified with scripting OpenLineage events, because in this case, you can list all the jobs that write to a certain data set, investigate their scan reports, and try to find out the difference. So, you have the job that was writing to a certain data set some amount of rows, and at some point it's not writing, it's the commit report is empty, and this is because the scan report had a low amount of rows read. So this is the example of the problem that actually couldn't have solved with just Iceberg metrics, because you're missing the correlation between commit report and the scan report. Yeah, so with OpenLineage, we fill the gap, and we are able to create even more rules. And you can, these were just the example rules. You can ask the AI to generate those rules for you. But actually, I don't think AI would generate those rules without OpenLineage and metrics, because if you're optimizing your jobs, you need to focus on the low-hanging fruits. You need to know where to focus, and if you're just parsing the SQLs to try to make them better, it's a great chance you will find out that someone has really tiny data set, and this optimization doesn't make sense. So, if you want to tell people to improve their jobs, you really need to find out the ones that will make a difference. Yeah, and this is where OpenLineage and metrics and collecting metrics from Iceberg definitely helps. So how it is done? So actually, we're correlating OpenLineage events with Iceberg metrics, and OpenLineage events they already contain for like 2 years a dataset version facet for each input and output dataset. And dataset version for Iceberg tables is basically a snapshot ID. So Iceberg scan and commit reports also do contain snapshot ID, so we can correlate those two based on the snapshot IDs. So OpenLineage implements an in-memory Iceberg metrics reporter, which is later consumed by OpenLineage events. It automatically registers this reporter, and if you had any other reporter registered within the Spark session, then OpenLineage will leave those two. So your existing reporter is still going to work. Oh, that's a painting. So the funny thing about the modern art is that you can look at it and try to create your own title. So I looked at this one and I thought it's like data catalog without lineage. In fact, it wasn't that like this. So it's Autumn Rhythm by Jackson Pollock. So yeah, if you have catalog but don't have lineage, and you see all the dots, you have indexed all the data sets, you know all the fields, but you don't understand what comes out of what. So you don't know the relationships, the logic behind it, and what affects the other things. Yeah, so it's good to ask yourself to do an intellectual exercise. What happens if I change a column name, a field name within my ecosystem? And the practical answer is don't do this, but it's good to know if you're able to predict what happens or no. And yeah, I think Lineage helps answering this. So some critics say about this painting that's unorganized and explosive. And someone said that about Jackson Pollock that he lets his mind go blank, let his hands go not random, but not deliberate. And actually, it's the way the data system has evolved within the organization. So it's not totally random thing, but yeah, let's not call it deliberate. Yeah. Okay. The other thing cool about ChatGPT and AI nowadays is that you can ask your favorite movie character to phrase in his words some of the statements you want to say. So I asked ChatGPT to rephrase to let Jeffrey Lebowski say that OpenLineage is more than governance, which is something I truly think of. And there are some cool things it invented. So yeah, it's about empowering folks to really understand their data journey. So this is what OpenLineage is. It's to make you understand the things better. It helps people groove with their data, not just govern it. I like this most. And because, yeah, Lineage can be considered a compliance and data governance thing. I believe that if you enrich it with metrics, it can be a way more. It can be an everyday tool for data practitioners. And I like the term that to help people groove with their data, not just govern it. So yeah, I hope this is what OpenLineage really does. So yeah, what else is good to know about Lineage? So it's good to know that cross-platform Lineage is the only way to do it right. So there are a lot of vendors that claim they do have Lineage support, and you don't need OpenLineage because you can make use of one of their solutions. And this is somehow similar to a railway and the time zone in the 19th century. So prior to the middle of 19th century, there were no time zones, and each city had a slightly different time, which differed only by a few minutes, but it was synchronized by the sun. But yeah, it turned out to be a problem when the railway connected the cities, and someone tried to write a timeline, and with a train departing at city A and yeah, accessing city B at some point in time, and they need to synchronize the time. So I think it's pretty similar to Lineage available within custom vendors solutions. So if your whole organization uses the data ecosystem from a single vendor, and so in other words, if a city is your whole world, perhaps you don't need a cross-platform Lineage. But if your organization uses different technologies to process data, different stacks, which is, I believe, the case most of the time, then the lineage only makes value if you're able to connect graphs from different parts of the organization. So if you're using Spark, part of the graph will be created from the Spark jobs. If you're using Airflow to trigger some SQL queries, it will also create part of the graphs. And you can use Flink for stream processing, and it will also be part of the graph. And only if you have the whole graph, or let's say having a whole graph makes way more sense than having just a part which you cannot connect. What can you do with this? So what's the casual adoption model of OpenLineage? So I think it mostly starts with the exploration phase. So what you can do is to turn on OpenLineage producers for the selected jobs, perhaps on a test environment, see some backend for Lineage like Marquez or Oleander.dev, and collect the events emitted and verify the Lineage coverage. See if you see the graph, see if you see any value out of this, and what can you do with this. So once you succeed with this, you can start making it go live in production. So you can turn OpenLineage on for all the production jobs. And actually doesn't mean going to and changing all the production jobs. You can do it just, the globally for the Spark. You can add an extra jar to all your jobs, and you can inject some configuration either through Spark config or either through env properties or either through the YAML file attached to a job. So you can turn it on globally for the whole env and make it work. So if you go to production, definitely it makes sense to try to find out some enterprise grade data catalog to consume the Lineage metadata generated, and because this is really helpful in getting value out of this. And you can also work with the community to increase the coverage, because I think there's a great chance that you will see most of the graph, but some of the parts will be missing because of some corner cases. And but there are companies that help with the professional support to resolve those issues. Perhaps some data catalogs do that. I know that Getting Data is doing this as well. So if you run into the problem and you would like to, submit a solution to open source, you can always do it on your own, and there you can also find a help that will help you to do with this. And the next level up would be to have multiple consumers and different use cases. So, data catalog is one use case. You can build alerting on the top of OpenLineage events, because you can even let people configure the alerting based on the some job parameters that can be passed from environment variables, Spark configs, wherever. You can also use Marquez REST API to operationalize the metrics and write such rules as we demonstrated through the demo to detect some common pitfalls and improve the performance. So the beauty of this is that you can have several applications that consume Lineage events and bring different kinds of value. And because you don't have to emit OpenLineage events to HTTP endpoint, you can produce them directly on a Kafka, and from Kafka you can do whatever you like. You can also deploy the Fluentd proxy that will allow you to split and copy Lineage streams into different backends. Great potential, and I hope you liked it. So thank you very much for having me here. I'm Pawel Leszczynski, and if you want to reach out to me, have any questions, please connect via OpenLineage Slack and ask me anything you like.
That was really great. Thank you so much, Pawel. We actually have a question here. It says, does it integrate with Snowflake S3 too, or just S3 to Iceberg, etc.?
So I know that if you trigger Snowflake queries from Apache Airflow, then OpenLineage events are emitted. for some or even most of the operators. But I doubt that Iceberg properties are extracted. Yeah, when you query Snowflake Iceberg tables.
Okay, brilliant. Thank you. I don't see any other questions that have come through, but thank you so much. So that's all we have time for then. Thank you so much for joining us, Pawel. That was really, really fascinating to listen to. So as a reminder to everybody, all sessions will be available on demand within 1 hour of the end of the event. And up next in track 4, we actually have decoupling metadata, leveraging queryable Iceberg tables for scalable cross-engine innovation with Cathartic at E6 Data. So see you there. Thank you, everybody.